For this one, we want to state whether or not this guy is a solution. I'm going to test it using synthetic division, so I put the 2 in the box. I write down my coefficients in descending order, which it looks like I'm not missing any terms this time. I bring down the 1, I multiply, I add straight down. And I know how to add. That's going to be a 6. Let's see. I multiply, I add straight down. I multiply, I add straight down. So this one gave me a negative 70, so this one is not a 0. I'm looking for a 0 for my remainder, which is essentially saying I'm looking for a 0 when I plug this thing in. Now it asks me to do the same thing with a 4. So I put the 4 into my box, I write down my coefficients. I bring down the 1, I multiply, I add straight down, I multiply, I add straight down, I multiply, I add straight down. So this one is a 0 because I got a 0 out when I did my synthetic division. All right? And now if we want to find the remaining zeros, again, we're still using the same problem here. Really, this guy tells me this. If the 4 divide evenly, it means that x minus 4 is one of my factors. And when I divided that out, it left me with this bottom thing, the 1, the 8, and the 15, which is a 1x squared plus 8x plus 15. So essentially what I'm doing is I'm solving this thing. I'm factoring it through division. And now I can set each factor equals 0, and I can factor this thing further. This factors into an x plus 3 and an x plus 5. So now I've taken something that I normally wouldn't be able to factor, and I've factored it into 3 binomials. Now I set each factor equals 0. X equals 4, x equals a negative 3, and x equals a negative 5. That's it, done and done. Looking at this next one, it's the same thing we just did, except this time we're not given one to start. You have to do a little bit of guess and check. So I'm going to look at values factors of negative 8, like 1, 2, 4, 8, and the negative versions of those. And I just take a guess. Maybe I'll guess something like a 2. And I write down the 1, the negative 1, the negative 10, and the negative 8. And I try my synthetic division. I bring this guy down. I multiply. I add straight down. I multiply. I add straight down. I multiply. I add straight down. So that one's not going to work. So I just cross that off my list. That one didn't work. So then I try something else. Maybe I try something like a negative 2. So I bring this guy down and I multiply, and I add straight down, and I multiply, and I add straight down, and I multiply, and I add straight down. And I find out that this one works, okay? Which means I've got factors of x plus 2. And then my other factor is the x squared minus 3x minus 4. And now I just want to factor this thing completely. This factors into an x minus 4 and an x plus 1. And now we set each factor equal to 0, x equals a negative 2, x equals 4, and x equals a negative 1. And that's it. I've found all of them. I had to do the first one by guess and check. Okay. The next one is very similar. I want to start with some guess and check. This time I'm looking at factors of the 10, so the 1, the 2, the 5, the 10, the negative 1, negative 2, negative 5, negative 10, in no particular order here. And then I just take a guess. All right. And we're not typically going to guess right the first try, but maybe I'll start with a 2 again. That felt good last time. The 1, the negative 6, 13, and the negative 10. So I bring down the 1, I multiply, I add straight down, I multiply, I add straight down, I multiply, I add straight down. And lucky me, I guessed it right on the first time. So that means this factors into an x minus 2 and an x squared minus 4x plus 5. And the issue here is that I can't factor that second trinomial. So I said this guy equal to 0 and get the 2. I said this guy equal to 0. And I have to solve by either completing the square or the quadratic formula. Okay. This one I would do completing the square for, so I'm going to subtract the 5 from each side. X squared minus 4x with a little space equals 0. I do b divided by 2 and square it. That's equals a negative 5. I do b divided by 2 and square, which is the 4. I got to add that to each side. This factors into an x minus 2 squared equals negative 1. I take the square root of each side. X minus 2 equals an I, or rather a plus or minus I, because I took the square root of each side. And then I add the 2 to each side. And I find out that x equals, and I just write it this way. I say a 2 plus or minus I. And so when I write that, I write it as x equals a 2 plus or minus I. And that's it. Okay? For this one, I'm doing f of g of 2, so I'm doing f of g of 2, which means I'm plugging the 2 into the g function. I'm doing g of 2 first, which means I'm just plugging the 2 in for x, so I do 2 squared minus 5, so that's 4 minus 5, which is negative 1. And now I'm doing f of negative 1, which is essentially telling me to plug the negative 1 into the f function. And when I do that, I get a positive 1, and that's it. And I do the same thing with the next one. This time I'm doing g of f of negative 4. So I plug the negative 4 into the f function, negative 4 plus 2, which is a negative 2. And now I'm doing g of negative 2, which means I'm plugging that into the g function, which is going to give me a 4 minus 5, which is a negative 1, and that's it. The next one I'm doing f of 3, so I plug the f of 3 in, means I plug a 3 into the f function, which gives me a 5. So now I have f of 5, which means I plug a 5 into the f function, which gives me a 7. For this one, the inverse of f of x simply means I take the f function and I switch all the ordered pairs. Instead of negative 4, 1, I do 1, negative 4. Instead of 0, 2, I do 2, 0. 5, negative 1, 5, I do 5, negative 1. And that's it. That's the inverse. I'm switching the x and the y. I do the same thing with the g of x function. I switch the x and the y, so that gives me a 3, 3, a 1, negative 1, and a 0, 6. Okay? If I look at the next one, this one essentially says this: y equals a 2/5 x plus 3. To find the inverse, I just switch the x and the y. Except this time I literally have an x and a y that I switch. Instead of having values that I switch here, I switch the x and the y's themselves. And now I just have to solve this for y, because I don't want to leave it in terms of x. So that gives me an x minus 3 equals 2/5 y. I can multiply each side by 5. So I get 5x minus 15 equals 2y. I divide each side by 2. And I'm just going to divide each of these pieces by 2. So I end up with y equals a 5/2 x minus 15/2, which back in my function notation would be this. And I write it that way just because it's in slope-intercept form, so it's easily recognized by us. Okay? For this one, I want to know if these are inverses of one another. So I can do my composition test. So I'm going to do f of g of x, and then I'll do g of f of x. And really, I'm looking to see if I get an x each time when I plug one into the other. Okay? So I do the first one here. I'm plugging the f of g of x, which is this guy, which means I'm plugging this entire trinomial into my f of x function. Okay, so I'm going to have this, the square root. I might have to move this guy a little bit. I'm going to have the square root of x squared plus 10x plus 25. And then the minus 5 on the outside of that square root. Okay? And now I want to simplify this thing. And right here, the square root, this trinomial factors into an x plus 5 squared. And it's important to see that, or you're going to have a lot of trouble taking the square root here. And then when I take the square root of this thing, it gives me an x plus 5, or rather, it gives me the absolute value of x plus 5, which is like a plus or minus x plus 5. Which means if I look at the positive version, yeah, it gives me an x. But if I look at the negative version of this thing, it gives me like a negative x minus 10, or a negative x if we just look at the opposite of the x value. So what happens here is I don't just get an x, I get this piece, which means these are not functions. And I don't even need to bother doing the second one because I didn't just get an x here. I know that these are not inverses. If I had a plus or minus out in front of this guy, then they would be inverses, because that plus or minus would cancel out with the other plus or minus. Okay?